Welcome, welcome, welcome to Exploration Part 3. My name's Blades, and yeah, what have I been up to? In the last episode I showed you how to set up Visual Studio. In this episode I am going to attempt to use Visual Code. Dun dun dun. So where are we up to? We wanted programming, didn't we? Yeah. So it's the same place. It's the same save files. As you can see, there's my Visual Studio solution and all the rest of the bits and pieces. The only things I've added so far is a profile for doing the build bat as usual. I don't think I've added, no, it's added that. I haven't done anything there. That's fine. And we have C++ Ccpp. There we go. Let's get rid of the terminal. I was messing around having a look, see whether that bat would work or not, and it did. Quick look at the bat. Build.bat is call my QMake, which is in Qt, and call the make, which is in Qt tools. I'll leave that on the screen a second so you can have a good look at that, how my pathing works compared to what your pathing may be for Windows. If you're on Linux, you don't need that. You just put build.sh, make sure it's executable by looking at the properties, and you just put qmake and make. You don't need all this silliness. I've put a pause on it, which I'm going to take off because I don't know what I didn't know what it was doing at the time, so I put a pause on there. We don't need that. So that's the batch file. That's it. The profile we will look into in a bit later. Oh no, I'll look at it now. I've got a profile. Here we go. It's target equals C++, template equals app, config plus equals console, C++ 11. Can we do 17? Don't know. Don't really care. C++ 11 is a good standard. I'm happy with that. Take minus equals app bundle, minus equals Qt, because I can't use it, obviously. That's why I'm using this. There's nothing in that lot. Headers plus equals, there aren't any. Sources plus equals backslash, and then on the next line down, c++.cpp. So a really simple. Oh yeah, Qt. I forgot about this bit, didn't I? Qt minus equals GUI and core, because it puts that in automatically. And the config plus equals debug. I obviously put a note below config plus equals release. When I want to do a release, that is. So that's how I've structured it so far. This part here is going to be for adding libraries, so really isn't needed at this point in time because there aren't any. So let's see if I can get all of that. No, I can't. Let me just pop that on the screen there for you for a sec, just so you can have a good look at that. Oh, mighty fine coffee. And the last bits down the bottom, which you can't see, are here. There we go. You don't need any of this lot. This is just notes. Hash means it doesn't use it. It's like the notes within C++, where you put dash dash. So that's my plus profile. That's going to be interesting if we can get to use it. Our massive thingy here. Module, namespace module, and then number. Should this be a library? No, not yet. And that's where the path to the GDB debug is, in case I need it later for doing this debuggy nonsense thingy here. Right. Let's see if we can do anything with this. It's going to be interesting if I can. All well and good. If I can't, it doesn't matter. I've got the Visual Studio solution, so ho hum. It's whatever happens, happens. Alright, now today's bits and pieces are going to be on strings, isn't it? I wanted to do strings first. I want to dive in with something pretty complex. Very, very complicated setup. So I've chosen this one to show you how powerful the language is that you can get from, what, 63 items, keywords. Right, yeah, we'll start here. Dev area. I'll mark this as. Put a few more of those on. There we go. Right, we've got a dev area. I like to mark things out, keep things tidy. Here we go. So I'm going to protect everything with a namespace. If I type into on this line right now a function, it will be in something called global namespace, which means it could clash with things inside that include. They've protected their include with the std : for the standard library. So that's how they protected theirs. That's their namespace, their std : But if I was to make a function std, for whatever, I don't know, reason whatsoever, maybe it would be a medical article, I don't know, then it will start clashing with the standard library. So we're not going to do that. We're going to have our own namespacing. So one of the keywords is namespace. So that's our first bit of C. ++ actually, not C. So namespace needs name. What did I call it? Module. So capital. Module 1. We'll call this one. And it has a scope. All things within the C++ have a scope. So this namespace will start here. Anything written in this namespace will die at the end here. Gets deleted. This is so that any resources taken from the overall system that you're working on will go back to the system that you are working on. It's a bit annoying if you start running programs and after using so many programs you run out of memory. That's not a good idea. So it's always wise to put things back in the system that you take out. So that's what a scope does. And you can use scopes within scopes, but that's a bit more complicated than I want to explain today. Well, we are about to do that anyway, so it doesn't really matter. The first thing I'm going to use is something called size t. Size_t, there it is. That is one of the reserved names, reserved keywords. Size t, I think it is anyway. I hope it hasn't got a definition. Oh, it does. It has a definition in standard def.h. It looks as though it could be a keyword. Not sure though. Doesn't look like it. It looks like it's a definition, a hash define, something they've made up for this. I'm not sure then. I would have to have a look, wouldn't I? Do I have my definitions anywhere? Let's have a look in here. C++ keywords. Here we go. No, it's not. So yes, it is a made-up word. It isn't C++. These are the 63 commands for C++. I can't really get it all on one screen. Can I minus that down a bit? Control minus? Yes, I can. So ASM is the first one. Minus it down again. There we go. That's the first page. That's the first lot. If you want to have a squint at those, that's page 1 of 2. And the other keywords are on page 2. And if you count them all, there's 63 of them. I know, I counted them. There you go. So that goes from register all the way down to while for looping. And it tells you what they all do as well. Isn't that cute? So no, it's not one of the 63. So that I can read it again. Some other time. Maybe. So, size t. It's a type. It's like int, float, an integer. It's telling us what type of variable is going to be returned from a function. And the function that we're going to name, the name of the function is going to be called split. This is for strings. Oh, I forgot. Did I tell you that it was about strings that we're doing today? Module 1 is going to be about strings. There we go. I'll put that down here actually, because we'll need a list of my modules, won't I, at some point. So module 1 strings. So module 1, what we're going to need here, we will need a couple of includes. So hash include, you've guessed it, string. There we go. And I also want another standard library, which is vector. So we'll pop you in as well. There we go. So split is the name of the function that we are going to write. So when we want to call this function, we will call it by module1 : and then split. And then we will open the brackets. So we'll do that now. And I want a standard string, but I want it as a const because it's coming from outside. Const is a keyword. As you can see, it's gone purple. Const means that we are not going to modify the variable, or in this case it's going to be a variable, which is a standard : string. Okay, that's why I needed this include. And the string, we are going to ask for its address, or we are going to not ask but take its address. So to take its address, we use ampersand. I'm just going to call it text line. Like that. So it's taking in a line of text, or a text line. Why not just call it line of text? Do capitals. Do it properly. Line of text. There we go. Now I can read it properly. So it's going to take in the address, ampersand sign, a line of text. Now why do it that way? It's because I don't know how big the line is going to be. I don't want to copy the whole line into the function because it could be quite big, and that would be memory expensive and copy time expensive. So all I want to do is, when they offer the line of text, I'm just going to take the address of it, which is very, very quick. And I'm going to promise not to change that address, obviously. because if we did, then the original program wouldn't know where to find it again. So it just makes sense. That's what the const is for. This is going to be fun. Let's use that standard vector. So standard vector. This is a complicated one that I wanted to look at. Now, if you have a look at my handy hints thing there, it says standard vector. It then opens brackets and says input iterator, input, yeah, it gives a load of rubbish. Okay. What we need at this point is to tell the standard vector what kind of variable we want to store inside a vector. Now, what is a vector? A vector is a list of items. And it's just going to be a standard string, by the way. There we go. It just means a list of items. So that, in my mind, just says a standard list of strings when I read that. I hope that makes sense. And again, we don't want to be messing around with too much. So again, I'm going to take the address of the name, and it's going to be, well, yeah, we'll call it split store. There we go, split store. Again, just the address. I don't want the whole thing, I just want the address. Makes everything nice and easy. The last thing we're going to need is a character. Character is a purple one again. That means it's a C++ keyword. All of that line there, standard vector, standard string, split store, is defined within that library. And that's how powerful it is. That library will break this down into its component parts and do the operations necessary for that to happen. And that's why libraries are so important. They make our life simpler and a lot easier. To do that in full, just using the 63 keywords, well, it could take quite a bit, shall we say, of programming. And this will save us a lot of programming. In fact, the standard vector, that vector include, to program it would probably take you a week, 2 weeks maybe. So yeah, that's a lot of work that's been put in there. I want a search character, don't I? I'm just going to call it search character. I can call it anything I want. There we go. I'm calling it search character because that means something to me in English. So that's why I've done that. There's no semicolon at the end. It's just return. And then we get our scope. And that is the scope of the function, not the namespace. Namespace has its scope. This function will live for the entirety of this namespace, this scope. And anything that we write will live for the entirety of this scope for the function. So you can see that those brackets are very important. It tells the computer when to destroy things, when to return resources back to the underlying computer that we're writing this on. Okay, this size t has to be addressed, so we're going to have that. Size t really just means I don't know what size it is. T means type, so size of whatever the type is. Yeah, exactly, position. I'm going to have as my first variable, I could have called it anything, it's a variable, so it's a variable name, and that is going to be line of text. Line of text, dot find. Find is part of the strings include. It's a function that they give us that helps us with strings, obviously. So find. It's a function. You can tell that because it's given me this kind of block, this cube kind of thing, symbol next to it. So that means it's a function, which means it'll come up in light blue. Lovely. I didn't choose the colours. Let's put our search character in there. Okay, and at the end of every statement or every command, we put a semicolon. Very important. That tells the compiler that that is the end of a command, and please compile it into assembly language. So that semicolon means end of line or end of command, that kind of thing. And size t, I'll need another one. I'll call this one initial position. You might notice I put capitals for the second word. I do that, it's my choice. I could have just said int initial position, couldn't I? Because it's just an integer, 0. I don't know why size t. It's just a convention that I use. Why? Because it makes it more readable. Try putting the lowercase p there, and it starts. The word starts merging together, and you're never quite sure where one word ends and the next one begins, and you can get very, very strange-looking names of things. So that's the name of something. That's the name of something. That's the name of something. That's a function that's already been pre-written in string library. We're doing well, and 0 is just 0. Always is. And split store, how are we doing there? That vector, yes. I want to clear that. So split store dot clear, do we have? Yeah, there it is. That just clears the memory in case it's got something in there already. It could well have. It might be pre-used. It might be something that's been used before this memory. I don't know where the computer's putting it in memory. It's putting it somewhere out there over the rainbow. Now we need to go through the whole of the positions within this line of, well, this string, really. So I'm going to use a while loop. While loops are C++. They are a standard. They are given to us as a keyword. So let's have position. Let's go through this position by position. And if it's not, is a pling. That's logical not. You know anything about logical and Boolean algebra? Good on you. If you don't, you can look it up, but not equals. And means if the position is not equal to the standard string npos, isn't it? Yeah, it is. Npos means there isn't one. In other words, you've got to the end of the string, you're looking for the next position, and there isn't one. There we go. A while loop has a scope, which means everything that's done in here gets killed off when we exit the while loop, unless we store it in one of these variables, whatever our results are. So we have to store, if we are going to determine values or store variables whilst in here, those variables have to be outside or declared outside of the while loop, which is why we declared them here. So we didn't just decide to do a while loop, accidentally kill them off and return a value that doesn't exist. Oh, we have to put a return value in, don't we? Let me just pop that in. Because we put that, we have to return a size underscore t. And we are... yeah, we can just return that, can't we? And it's going to be split store. Because this is splitting down a string. If you hadn't already guessed. That's what this function does. It takes a string and splits it by the search character into a list of separate parts of the string, so that you can split strings more easily. Yes, that's what it does, and it's not included within the string standard library, so we're writing it ourselves. I don't mind. It's not given, so we're doing it ourselves. So split a store. Yeah, split store. We are going to do an action on split store which is provided to us. It's going to be called push back. There it is. It's a function given to us by the vector library. What that does is it will push whatever we put in these brackets to the bottom of to the back of the list, or the back of the queue, or whatever you want to think of it as. I always think of vectors as a list, so to the bottom of the list. Let's see, what do we want to put in here? We want the text line. Sorry, we want the line of text. Silly me. We want the substring. Do we have one of those in here? Yes, we do. Excellent. So the substring of initial position, and then it will be position minus initial position. What that does is it takes your string at position whatever, and it will take from our initial position, which is 0, so there you go, minus 0, so the first one it takes is from 0 to wherever it is, and it will create a string out of that and put it to the back of our list, or the bottom of our list. 2 brackets at the end, yep, that's correct. Brackets have to match up. So there we go, that's the pushback. That's the easy bit. Now we say initial position. Is it just plus plus on this? No. It equals the next position available. Because we've already stored up to position, so it's going to be position, and just add 1 to that. That'll be fine. Okay, so we store it, and then we set our initial position to the next position available. That's how that works. You can see how that's going to work. It's just going to take chunks, chunks of our string, which we are using search character on to find which character we're splitting it up by, and we're just pushing it back. Yeah, that looks okay. Does that work for me? Position equals line of text dot find. Yeah, okay. As long as position doesn't equal that. Yeah, okay, I'm happy. Looking good so far. The position for the next one will equal the text line, or line of text, sorry. Line of text dot find, and we need to know where the next one is. Search character, but this time we don't want to search from the beginning. We want to search from the initial position, which is that. Instead of searching from the very beginning of the text, like we did here, we're just going to go from the next position, which is initial position there. It's been altered, and then we're just going to search along for the next character that comes up, and it'll go through again, and it'll push that back. That's the idea. That's your while loop done. Yeah, that will separate them all off bit by bit using the search character. Clever, huh? Now, because the while loop comes out a little bit early, like one position early, we do have to do a little bit more. We have to do an extra pushback for the last position, because he doesn't get caught. That's my bad, I suppose. It's just the way it's written, unfortunately. So I'll take out line of text, and again it's just going to be dot substring. Yep, that right. Yep. Initial position, comma. This is where it alters, because we have to take it to the end of the line. So it's std colon colon min for minimum. It's a template class, lovely. And it's going to be position. This is an awkward line to write. Line of text dot size, depending on how much of the line is left, and two closes. Just want to come outside of the brackets. There it is. And then it's minus initial position plus 1, because we wanted the next one, and that's the whole line. A very complicated line. So what we're doing is we want the line of text, we want the substring that goes from our last detected position, which is initial position plus 1, to the end of the line, which is line. That's that bit there, that's the end of the line. So that will take us to the end of our line of text. Yay! So that means we've done them all. Done all of the searches, including the one that failed at the end. Yeah, because obviously, unless you put the search character as the last character in each line, it won't find them. There we go. And then, of course, we just return it. Now, we can split these lines up to make them more readable, and on this one I'm going to do that. So I'm just going to hit return there. Tab it in. Yeah, that'll do. There we go. See, you can read it all at once without it going off the page. Silly. That's it. That's the whole thing. So what I want to do here in main is give myself some text. Standard string. Call it text. And we're just going to put this is a line of text. Full stop. There we go. I've now got a string of text called text. We are then going to create a vector, which will be that vector there, and we're just going to call it I'll call it split store, I suppose. I don't know. So a standard vector. This is how you would use this. We'll assume you use this in Qt if it's in the last series. It has it done for us in Qt. Unfortunately, C++ doesn't have it naturally, so I had to write it whilst I was doing that series to do a proof of concept thing, which is why I'm showing it in here now. This is just going to be a standard string. and all I need here is a name. Call it splitline. Doesn't matter what you call it. Call it Bob's your uncle. I'm not really bothered. Right, so there we go. We've got a string. We've got a split line. So split line will equal, remember, I want to know what it is. So let's do that then. So split line will equal, and it is module 1 ::. It'll come up automatically. You see how it's got the little box by the side of it? It already knows it's a function. So there's our function. It now tells us that we need all of this garbage, and that's how it interprets this. So it's a string. So we'll put one of those in. That's text. Comma. It now needs our vector. So that was splitline. And it needs a character. Characters are usually done like that. So that's a space between those two characters. So I want to split it by space. That'd be a good idea. And that will do it. That is now the complete function line, except equals doesn't like it. Oh god, what is it? No operator equals these operands. Blah, blah, blah. String allocator equals size t. It doesn't. Well, that's interesting. According to C++, yes, it does. Just one moment. What have I done? Come on, Blades. You've probably done something wrong. You know what I'm like. Let's see how I was splitting lines, shall I? I used to think I knew what I was doing until C++ changed at 17. There we go. Okay. Ah. Yes, we don't need that. That's there, isn't it, already? Oops. It's not an equals at all. We just call it. We put our text in there, we put our split line in there, and we put our character in there, and everything will be dumped into split line for us, won't it? Yeah, okay. There we go. So that is your first very complex function to look at. Functions are usually a lot simpler than that. It's just one that I cooked up on the spur of some moment because I needed it. Now I'm going to write a second function, and our second function is going to place that split line onto the screen for, well, into the console for us. And I'm going to call this what can we call it? Split to console. So doesn't need anything, does it? I don't think so. Wouldn't have thought. No, it's just a void. Means it doesn't return anything. So yeah, I'll call it. Am I using capitals already? Yeah, I am. Split to console. Open brackets. I'm gonna overcomplicate this one again. We've already got IOStream going, so we've already got that available up here. So what I'm going to do is I'm going to use what is in IOStream, and I know that there is a standard outstream. So that will be standard outstream. There is second one down. So I'm going to need one of those. Call it printout. I'll just take the address of it because I don't need the whole thing passing to me again. You'll notice that a lot tend to just take addresses when taking things in. It's because I don't want the whole thing sending to me and placing into this function, because it's only going to get deleted at the end and returned to the system. So just take the address of where it is in the memory. A lot easier. Now I'm going to need that const, because we're not going to alter it, and of course it's the standard vector that we're going to be placing in the console. Vector, yeah, of strings. So it looks complicated, but it isn't. It's just a big command. Again, it's the big commands that people get wary of, and that is vector to print. There you go. That means something to me. I don't know if it means anything to you. Changing the names. These names, like printout and vector to print, you can change them. You don't have to call them exactly what I do. Again, there's no semicolon at the end. At the end of a command, there is. At the definition of a function, there isn't. This is a definition of a function. Let's have a for loop, because it's going to have to do the whole thing, isn't it? So for, and it's going to be size underscore t. I'll just use count equals 0. This is how you do a for loop. So you set the variable that you want to count by. You can have any variable of any type you want. Then you set the condition that you want it to loop around by. So for count equals 0. The highest number of count is going to be less than vector to print dot size, depending on its size. So I don't know what size it is, so I'll have to ask. And then we're just going to count up. So plus count is really count equals count plus 1. It's just a shorthand way of saying count equals count plus 1. Or count plus 1. Yeah, oh, never mind, it's complicated, that bit. You can put the plus in front or after. In front it will pre-count, after it will post-count. There we go. I'll go down to the next line for the for loop. Now you can put a scope on a for loop like that, if you want to, but I'm only going to be, oh no, I'll do it properly for you. There you go. So you put your for loop, you can have a scope, so everything that happens within here dies at the end of that scope. And all we're going to do is print out. Ooh, no, we're not going to do it like that though. Printf, no, print out. Thank you. Print out, and we're just going to send to it, which is, that means stream. Believe it or not, those two left arrows mean stream in this situation. It also means something else in another situation, which we're not going to talk about. And that's going to be just print out. We're going to list it on screen, aren't we? std : and line. That's a function that we're allowed. End of line. Okay. So we're just going to go through each of the bits in our vector, print them out and end the line. Lovely. That looks okay. Why have I got a problem there with printout? IOStream. Oh, I beg your pardon. IOStream, please. Go away, you. I want the outstream, not the outfile stream, or whatever OF stands for. So print out. So we're going to print out. That doesn't look right. Yes, I have missed that bit, haven't I? There we go. I'm an idiot. Helps you print out what you came here to print out. Second one down. Print out. And what we're going to do is just print out vector to print. And we can choose which one it is using the count. So which bit of the vector we are using. So that will go from 0, the first item in vector to print, to the size -1 vector to print, and print out all its bits and pieces. The reason why we don't go to size itself and put an equals sign there, like less than or equal to that size, is because the last character is end of vector, or end of file, or end of string character, and we don't want that one. So we always go less than. If you ever wondered why it was done this way, that's why. It's because that extra one that we don't look at is just something that's being used as it's just an end of marker for the vector. So it's where the end of marker goes. It's the same in files, same in strings, same in all arrays, and it's the same in vectors. So we're treating it like an array there. That's how we do arrays, by the way. Better put semicolon at the end, don't we? It'll complain. Will that work? It will, but why am I doing it like that? Take that off. I know what I can do. Cut that out. I can put that there, std, colon, because I want to take this bit out afterwards, don't I? Semicolon. 2 semicolons now. After this has done the for loop, I will add an extra one. Just for now. Just for now, don't worry about that. Bring that back. Always have a space after a for loop. Do we need anything else? Shouldn't have thought so. No, that'll do. So we can now tell split to console where we want it to send our printout to. So it could be whatever, a file logging system, but in this case we're going to use cout, I think. So let's do that here. Let's see how we do this one. Can I remember how to do it? Well, let's just follow what it says. So this one, isn't it? So it's going to be module 1 still. Module 1 colon, that's the namespace. Split to console comes up now. Open brackets and std colon cout, comma. Cout means console out. Part of the standard library, console out in the IOStream. And then we just need our vector. So where we got that split line. There we go. And I'm also going to add system just in case I need it. No, okay. I thought it was just system. It is just system if you can spell it right, I think. Yeah. There we go. System pause, just in case I need it. I'm just putting that in because I don't know what's going to happen. Because I'm about to run this program. That's going to be interesting. I might need some help doing this. So let's have a look what I've got in here to help me. I have tasks. Here we go. Yeah, right, I've got some task stuff here. Okay, this is just a copy from something else that I've done, just saying tasks.json. So let's see. If you are on Visual Studio 2019, by any chance, you just click the little green arrow next to debug up at the top and it'll run it for you. And it should do what it's supposed to, or give you an error. One of the two. Hopefully an error. So, terminal. First of all, close this, otherwise this machine doesn't do it right. So, terminal. Run build task. No build task to run found. Okay. Create tasks.json. Thank you. Others. Thank you. And that will be, I guess, /build .bat. I'm guessing. Or just build.bat. Can't see why not. And as you can see from here, this is from Linux. I've used build.sh. You can tell it's from Linux. I want that last bit as well. And that comes after command. So that will be comma. There we go. Put the group in. Make sure that's right. There we go. I always reference back to other stuff that I've done if I'm not too sure, because I've never really programmed in JSON. JSON and Lua seem to be quite similar languages. Lua I understand because it's more like C or C#. But this JSON language has these square brackets in. It's like they put square brackets there. I would never program that way. I would always put them here so that they're on the same line so you can see them, that they join up. So tasks has this instruction block. It's like a function block, and within it it has two scopes. The first scope is for everything and the second scope is for groups. That seems to make sense in my mind. Shall we try running it? Exited with code 1. Okay. BYLD. Let's see if I've got any other JSONs that I can look at. Did I do a test one for myself? I did. Oops. No, go away, cancel. Let's have a look at the test one. Yeah. So build. We can call it anything we want. What's this? C++. That's what we'll call it. And as you can see, right, so I used that, did I? Workspace folder / right, we'll have to be careful there, because it's workspace folder, which is programming, and then it's going to be / C++ / C++. / Let's try that one. Did I change anything else? No, not there. Shell, yeah, okay. That's exactly what I've got then. So that should be correct. Run build task. Okay, it's done something. That's fantastic. Defaults to blah blah blah. Oh, right. Well, it worked. Right, what's it? That's a call, right? No target specified, no make file found. Right, so the make part didn't work. That's good. As long as I know what's not working, it's when I can't work out what's not working. So our build batch file looks like that. What did the test one look like? Let's go have a look. Let's have a look in test. Our build looked like that. Yes, love? Prescription. Why have I run out of things? No? I haven't run out of things, have I? I haven't run out of patches.
Have you still got patches?
No idea. I'll check. Prescriptions, yes. I know. So the only difference I've got there is there's no exe at the end of that. No idea why. That's okay. I'm just wondering whether we need to cd into here first. Because that looks like it's a working directory. Yep, no. Do we need to cd? Change directory? Probably. There's a simple way around it. What I'll do is I'll show you it build. Bin this. I'll work on that after, because that's my problem. New terminal. Let's see where it puts us. Yeah, it does. It puts us here. So cd C++ /C++. I should put us in the right directory. What? There we go. So that's the correct directory where the profile is and everything. I bet it is that cd. Build.bat is there, so build dot bat. Yeah, that worked. Which puts into debug our exe. So cd debug. Oops. That one, please. Let's get back in here. cd debug. So it's building all right. And it's just... I can't remember how to do it on Windows. I'll just put C++. .exe, I suppose. There you go. Hello from C++. This is a line of text. As you can see, it split it and printed it out exactly as I wanted it, with broken down. If you want to check that it's doing everything correctly, go to you a minute, and you bring back up. So that's our first program. Yay! C++. There it is. This is a line of text, as you can see. If I use the same idea here, which is std cout, and we just put text, and then std : endl semicolon. That's how you would print that line out to the console. Just go back up one, and it was build. There we go. And that was just that. It hasn't built it because I didn't save it. Silly me. Okay. Yeah, okay. So let's build it again. Is it just build? Yeah. There you go. This is a line of text. This is a line of text printed out two ways. Now, before I finish, though, I do want to modify it. I do want to take the extra end line off, because I'd like it to do both of them exactly the same. I could do it by I. I mean, to show it work, I'll do one more test on this. I'll show you what I mean. Just to show you that it's splitting properly and that this isn't a setup, we'll change the character from space to the letter I. Save it all out, and I can now just do build. Sorry, I'm having to do it by console, but hey ho. There you go. But you can see that the I disappears. Now, is that what we wanted? Did we want the I to disappear or not? That's the only thing I've spotted that could be wrong with this, or something you must be aware of. You wouldn't obviously normally split a line by the letter I, but it could be important. You might choose that the letter I is the line splitter. Well, you probably wouldn't. You would probably do /I as, you know, like an escape character I, /I as the line splitter or something like that, and have that inserted into your strings wherever you want them. I use space because that's most useful. So that's how it works, and what you've got to be aware of. As you can see, the letter I has been taken out. It's actually quite a good test, that. This is a line of text, yeah. Because we'd have to minus 1 off the search parameter. Somewhere. But hey ho, that's something else to think about some other day. But it all works, there you go. That's how you split a line, or how you can define it in your own split line function. I'll put that back to space because it makes more sense to me. But there we go. Bin you, don't want you anymore. I'll go away and work on how to get this fixed. I think we just need CD in here. It would be C plus backslash C plus plus. Save that out. Now the cat's having a go. Everybody's having a go today. Oh, this is. Ah dear. Oh, that worked. Doesn't tell you that it worked, but it worked. This is why I put that pause in, because I can't tell. Terminal. Run build task. There you go, it's working. Excellent. Yeah, it just needed the thingy doing. Right. So we've got a build system. I can take the pause out now. That's just so that I know what's going on. So yeah, there we go. That's our build system. CD into the correct directory from programming or wherever your top directory is. So we had to CD into C++ and C++. Why there's two things? That was Visual Studio 2019. That's its setup. That's how it does things. Because it puts the solution there, which is in the first C++ holds the solution, the second C++ holds the actual project. So this is your project directory, and that's the solution directory, and gets confusing. That's why I wanted to come to this, so I can get probably rid of that. But I'll clean that up as I need to. Excellent, we got it working. I'm quite happy about that. That is better than I expected. It's all working, it's all fine, and all we've done is written two functions. So you've now got two very, very complicated functions to have a look at and see whether you can understand them or not. The first one returns the values in there. The second one returns nothing, there's no return value, so it's void. And that return value isn't needed because we've got the address. So I have no idea why I'm returning it. Test. Oops. Got no idea why I'm returning that value there. Shouldn't need to, really. According to theory. According to theory, everything's possible. So if I put a void there, it should still run. And if it does, I want you to tell me why. In the comments below, why it still runs. I know why, but does it still run? Terminal, run build task. And that's all you're going to do, is it? Thanks. Where am I? Oh well. And it's C++. hello from C++. This is a line of text. This is a line of text. Let's check. Just one moment. Delete. So there isn't one. Terminal run build task. And has it worked or not? I can't tell with this thing. Yes, yes it has. There you go. It's just this doesn't update. Yeah, it's put it back in. So now I'm running the new one. Okay. That's the new one and it works. Tell me why. It's not returning the values anymore. So why does it still work? Dun, da, 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 dun, da, da. Good question. And I will answer that in the next episode. So there's your homework. Why does split still work after removing the return value? Because it now doesn't return anything. But it still works. And it's a clever trick from C. It's the way they used to do things in C, and this is obviously done in a C style. I can tell that by the way it's been programmed. And the way I had to change it to work properly. So there you go. There's your two functions. You've got a print. I'm going to change the name on it. I'm going to call it print what is this? Split string. There we go. Copy. So you got some homework. That now doesn't exist until you do paste. Yeah, print split string. Still works, don't worry. Why does split still work after removing the return value? So it's not actually returning anything. There we go. Interesting thing. You might want to look at it, you might not. You might want to spend more of your time just trying to understand what on earth all of that lot looks like. I won't be going through it again, so just watch the video again and see if you can understand any of my ramblings of how it was supposed to work. Now you see what it does. Done. All done. And I've got lots of things to sort out here and save out. So I'll leave you to it. Thank you for stopping by. Thank you for watching. I will catch you in the next episode where I will be doing some more random stuff and exploring C++. So in the meantime, take care, explore and have fun.